Have you ever looked at your hands?
Yeah.
Yeah, it's all scarred off for
Are they the same?
No.
No.
They're not?
No.
What are they of each other?
Mirror images.
Asymmetric?
Yeah.
Does a glove from your left hand fit the glove from your right hand?
No.
If it's ambidextrous, right?
Yes.
So your hands are not the same, okay? They're not the same, but they are mirror images of each other, yes?
Yes.
When you put them like this, they look like they're images of each other. And when you go like this, one on top of the other, you cannot put them on top of each other and look the same. When you can put them on top of each other and look the same, that's called non-superimposable. That's too much English, huh? Who comes up with that stuff? A biologist does.
That's what happens with the
They are non-superimposable mirror images. Okay? I just told you that when you can place one on top of the other, it's called non-superimposable. Okay? And if they're mirror images, there is a special name for that, and the name for that is enantiomers. Yes?
When they're mirror images, you said?
You don't know what I said. Don't worry about what I said. Look here.
Is what?
Are these two the same thing, yes or no?
Yeah. Yeah.
Are they the same thing?
No.
Yeah.
Yes. Yes.
You can put them on top of each other.
Are they the same thing?
Yes. No. No, they're not. They're not. The red is one way, the red is the other one. No.
So, you know if you go like this, can I put one on top of each other and do they look the same?
Yeah.
Yes. So they look the same. They are the same molecule. If I change any of these two groups, I will create a different molecule. I'm going to change the black one for the red. Whoops. And with a stick. I change the black for the red. Yes? Are they the same?
No.
Are they the same now?
No.
When I try to do it, the blue with the blue and the red on the top, this black, it's not in the same place the other black is.
No.
There is no way. But they are what of each other?
Mirror images.
They are mirror images of each other.
Right.
And they are non-superimposable.
Gotcha.
We are going to draw these things. That is in the plane of the board, 109.5 degrees apart. I am going to draw this thing that is going towards the back, and this is coming towards the front. Yes? Let's say you try to draw the mirror image of that.
Okay.
How would a mirror image of this looks like?
Just so you see
Like that?
Yeah.
You agree?
Yes,
Yeah.
yes.
I drew this towards the back, still that, and this towards the front. I put the CL here, the H there, the BR here, and the CH3 there. Okay? Those are mirror images of each other. Now we're going to call, we need a way of naming this, and way of naming this is called the RS system. The RS system is for naming chiral centers. And you'll have chiral centers when you have an sp3 hybridized carbon with 4 different groups on it. What?
The next one?
Sensor.
Yes, chiral center. Doesn't look like that, but that's what it is. What does it look like? CF, U, that's not a T, right? That's a plus.
It doesn't have
Okay.
H.
Another F and an N.
The F looks like, I don't know, C, F, I, H, E, R.
Okay? So here's what's going to happen on the test. On the test, you are going to have things like this. And what I want you to do is mark with an, what is it called? Asterisk? Is that a word?
Yes.
It's like this, yes? A whole bunch of them. The chiral centers in that molecule. You guys forgot a 3 here, didn't you?
Chiral centers.
How many does it have? How many?
Four
No,
different
total.
groups.
How many? How many in total?
4, 5.
Is this a chiral center?
Yeah.
That's not a chiral center because it has hydrogen, hydrogen, hydrogen. It's not a chiral center. Is this a chiral center? No, because it needs to be sp3 hybridized. Is this a chiral center?
Yes.
This carbon here has this group, that group, they're different groups. Has that group? and this group, they're different groups. Since it has 4 different things, this carbon, that's a chiral center.
Okay.
Okay, you try to do it for the rest.
All right.
Okay, how about this? Is this a chiral center?
Yes.
This is a chiral center because
It has one.
it has, that's the CH3, BR. That is different from this, yes? 4 different things on it. How about this? Is this a chiral center?
No.
No?
No,
Tell me what?
no.
But you have
Because it only has,
it only has 3 bonding things.
it's only a carbon with hydrogen.
Well, you don't draw the hydrogens a lot of times. I drew it
Okay, so
here.
then yes, it is one thing.
But this one cannot have 3 bonds. Otherwise, it has to have a charge.
So the hydrogen is inside.
So the hydrogen is there.
Yeah.
I didn't draw it,
So
but
it
it's
is-
there.
So it is,
So don't you draw it, so you have to know that the hydrogen is here.
unless it's a charge.
Unless there is a charge, yeah.
Okay.
So then it is one.
So
Yep,
yes,
so
it
it
is.
is one.
Yes, of course,
Yes.
this is a chiral center.
Mhm.
It has the hydrogen, it has whatever that is, this, and that is different.
Correct.
How about this one?
Yes.
Yes.
Another chiral center.
Yep.
How about this one? No.
Yes.
Yes.
Yes, it
It
is.
has the hydrogen on there.
That's right. It's no
This is a
charge
chiral
on it.
center because it has a hydrogen.
Hydrogen on it.
Whatever that is different from whatever this is,
Mhm.
and that, and a hydrogen that it has. How about this here? Is that
No.
chiral?
No.
No, this is not chiral,
No, it's not.
because it has 2
Two
hydrogens.
hydrogens.
And once it has 2 of the same groups, cannot be chiral anymore.
Gotcha.
How about this one?
No,
It has 2 hydrogens, it's not chiral center.
same thing.
How about this one?
No,
2 hydrogens, not a chiral center.
gotcha.
I'm gonna give you a crazy molecule on the test, and I am going to ask you to put these things wherever they're chiral centers, okay? Yes?
Yes.
Wait, so question. Of this group, because it's like 2 hydrogen or just 2 of any element? It's
2 of
not
any element.
Any element.
2 chlorines, 2 bromines, 2 methyls, whatever.
It's not the same.
Well, I'm glad at least you're having fun in my class. If that's funny, you will see how funny it is later. Later's gonna be hilarious. Okay, can I erase it? You guys still doing this?
Okay.
Now, if you have one enantiomer and you want to get the other, what do you do?
Draw the mirror image.
Yeah, sure, draw the mirror image, but if you want one enantiomer and you want the other, all you have to do is switch 2 groups. If you switch 2 groups, it will go from one enantiomer to the other. One is R, and if you switch 2 groups, what is it going to become?
Non-super.
S. No, don't worry about non-superimposed. This is R and S. One enantiomer is R, and the other enantiomer is S. And this R and this S is for the rotation. But it's not a normal rotation, it's a rotation according to priority. And the priority is based on molecular weight of the carbon directly attached on it. So I guess you can call it atomic number, or you can call it molar mass. I don't know what you're gonna call it. But which one has a higher priority, carbon or oxygen? Oxygen has a higher priority. And which one has higher priority from these three? Fluorine. So if I am assigning priority on this, the lower priority will be 1. Yes or no? No. Highest priority is 1. Lowest priority is 4. Okay?
Professor, did you say atomic number or molecular?
Molecular weight.
Well, I said so. Because most of the time the atomic number is more or less the same thing as a molecular number. Not all the time.
The same thing as a molecular.
You ready? We're going to have our carbon. The lowest priority has to go towards the back. And that will be, let's say, priority 4. But it doesn't really matter, okay? So if this is 1, this is priority 2, and this is priority 3. This rotation is what way? To the right or to the left?
It's to the left.
To the right.
To the right.
It's going like this, yes?
It's going clockwise.
Clockwise, isn't clockwise to the right?
Right, yes.
I mean, clockwise is like this, and this is my right.
It's going to the left.
Yes?
Correct.
It's going to the left.
Oh, yeah, this is your left.
Start to the left. Whatever. So it's going
Okay, whatever, okay? R is to the right. I mean, that makes sense to me. Here's my right, that way. So that's clockwise, that's R. So this is R. And S will go where? The other way. Okay, so how would it look? In order for you to determine this R or this S, the lowest priority has to be pointing where? Towards the back. If your lowest priority is not towards the back, you might have a problem and get this wrong. So if it's not in the back, you are going to place it in the back, or you are going to, I don't know what you're going to do, put yourself in the shoes of this thing. So let's say that this is like this. I am going to switch. I drew the same, yes?
Yes.
I did not draw the mirror image.
No.
I drew the same. And I am going to change 2 groups. Which groups do you want to exchange?
3 and
Except 4.
3 and 2.
3 and 2.
I want 3 and 2. So here will be 2, and here will be 3, and here's 1. Where is this rotation?
Left.
Don't let her say it, because she's gonna say it the other way. Guys, the rotation is like 1, 2, 3. 1, 2, 3. Yes, 1, 2, 3. Like this, clockwise. This rotation is 1, 2, 3. You see it? It doesn't matter you went through 4,
Oh, okay.
because
Okay.
4 is in the back.
Okay, gotcha, gotcha.
You gotta go through these 3 that are like this in the front.
Makes sense. Right.
So this looks like this, yes?
Right.
That's how it looks. I mean, you are seeing this here, but this is what you look at,
Okay. Gotcha.
okay?
Wait, what is it you look at?
I was writing down, I'm sorry.
The numbers.
Skip the 4 and go to the
And don't worry about where the 4 is.
skip it.
So, R right. Yeah. R right.
Determine if that is R or S. Don't say it. Draw the stuff. Assign priorities and then write it on your paper. This book went crazy on this chapter. Yeah, you can talk to each other if you want. What is it?
Are you basing
The
it on-
lowest priority is towards the back, yes or no?
Yes.
Correct.
So you-
Protein is more.
You did not have to do it. Now I have to assign priority based on whichever one is
Higher, right?
bigger and fatter.
So from
Which one is the biggest from all of those?
bromine.
Bromine. So this is priority 1, this is priority 2, and this is priority 3. It's not of the whole thing. It's only of the first element.
Oh.
If you cannot,
Really?
Just the first
yeah,
element.
really.
Oh, I still got the same answer.
What happened?
I said I still got the same answer and I didn't know.
It's okay, I'm just telling you. That's why I wrote it like this so you wouldn't have that problem. Because it's one step at a time, okay? It is just of the first element. If you can't decide on the first element because there is a seal here, then you know you go to the next element.
Okay.
Not like that. And I'm not gonna give you complicated ones because I don't care. We have a lot more to do. So this goes what way?
Clockwise.
So this is R. Now I want you to draw S.
Okay.
I want you to draw S as the mirror image of that. And then I want you to draw the same thing and then draw S again. Okay.
Wait, what?
Okay.
So mirror image, okay.
Mirror image of that in S. Okay.
Draw the mirror image of this. And then draw the same thing here, but make it S now.
Oh, okay.
Don't act silly because that's what we have been doing.
Yes, sir.
I mean, I should just wink at you and you should just do it. That's how far a relationship is, you know? By the way, how is this important for you? Huh?
What do you mean, how is this important?
Yeah, is this important in your life? Are you ever gonna see this again?
Yes. Or go to.
Drugs.
Yeah,
Put it this way, some drugs, only the R is active and the S is not. That's why you have to know. Plus it's in the book. By the way, do you know that amino acids are chiral, except for one amino acid, which is called glycine? The rest of the amino acids are chiral, and only one rotation is known in nature. Amino acids only rotate one way, no matter who makes it, where it comes from, whether it came from outer space or from here. And sugars or carbohydrates are the same way. Only one type of sugar is made in nature. The rest is not.
Sucrose?
No, not sucrose. Rotation. You don't know. D and L are the rotation for sugars. Anyway, don't worry about it. So, what is it for this?
So, what would it be?
We got 20 minutes, okay? So,
power centers
let's draw the same.
Switch the spot.
Let's draw a mirror image, yes?
Yes.
You agree?
Yeah.
And this is towards the back, and this is towards the front. You like that?
Correct.
I'm going to leave the H in the back. I'm going to put the CH3 here,
Bless you.
the CL here, and the BR here. Number them and see if it is that or not.
Counterclockwise.
Difference.
Counterclockwise.
2, 3.
I don't know what counterclockwise is. I know one is R, the other one is what? Is it?
Yes.
You sure?
Yes.
Yeah, it's counterclockwise.
I don't know. This is towards the back. This is 1.
Uh-huh.
That's
This is 2.
2.
No.
Yes?
No.
No.
CL is 2.
And this is
CL
3.
and that's 4.
So this is
counter.
S.
This is S. Very nice. Now, if you draw the same thing as that,
And switch.
Yeah, you just switch
You
CH
switch the
to
chlorine
CH3.
and the CH3.
what do you want to switch?
The
The
chlorine and the
CH3.
methane. Chlorine and the
There
methane.
you go.
Yeah.
This is 1,
That's
2,
and that's 3.
and 3. The rotation is
Counterclockwise.
that way. Is S. Outstanding. I'm not gonna lie to you. I believe that you guys are gonna get this right on the test. But then I give you the test. And I go home crying. All right. So, a life was not going to stay that simple forever, was it?
No.
No, of course not.
Wait,
What do you mean, wait?
when we draw this on the test, do you want us to do like the
Well,
direction of the arrow?
What happened?
When we draw, like, I'm pretty sure we're gonna have to draw this on the test, right? Okay, so do we have to put like the direction of the arrow?
Yes, and you have to put the 1 and the 2 and the 3 and the letter. Or you planning to look at somebody else's letter and then go, oh yeah.
Excuse me.
What? What question would you ask? R, S.
Yeah.
Draw the other enantiomer. Draw one like the mirror image and one that is the same thing, but, okay, I'm winking at you.
So when you first started this, you said in order to get a mirror image, you don't need to just draw it, you can just switch the groups. So if we gave you either of those S's, for in that example, it would be correct?
Yes.
So for every one you presented, we need to draw two. One that would
No.
be a derived image.
You need to learn how to draw them both, because on the test I may ask you, give me the mirror image. Or I may ask you, don't give me the mirror image, but give me the S of this one.
Okay.
Or I may draw it for you, and then you tell me if it is one or the other. Yeah.
How come hydrogen is not the front priority?
In the back.
Yeah.
Hydrogen is the fourth priority, but I did not draw it that way. It is up to you now to figure that out. Because I wasn't planning on writing them easy for the rest of my life.
So
You can
this is
flip it,
another Brenna's, like, what we were doing.
You can flip it.
Like we can rearrange.
I think, I don't know if it's illegal.
I don't think you can switch it.
They catch you, you might go to jail, but it's illegal. You can do it. Did that sound?
You're saying you switch it.
What is it, R or S?
R.
S.
I didn't see the one.
S.
Why are you looking away?
Okay.
All right, let's find out, okay? Now, here's the idea. This highest priority, the lowest priority is supposed to be where?
In the back.
In the back. It's not supposed to be in the front, but it is in the front. Let's assign priority. 1,
2,
2,
3.
and 3. If I do this, it looks like what? It looks like what? It looks like R, yes?
Yes.
But this is in the total opposite of where I'm supposed to have it.
Right.
So it cannot be R. It has to be the opposite of this because the hydrogen is completely opposite to it.
So you
So
skip the
this
hydrogen
is
and go back to
S.
Yeah.
That's one way of doing it. If the hydrogen is in the front, you just
Skip it.
assign the priorities and it's the reverse of whatever you get. It was R, yes or no? This looked like R, but it's not R because the hydrogen is in the front.
Okay.
So it is S. That's one way of doing it, yes? Now let's do it another way. And the other way is by forcing it to be what we need it to be. The bromine is going to stay where it is, and the Cl is going to stay where it is. Now I need this hydrogen to be where? In the back. And the CH, well, we're going to put it in the front. I took the hydrogen to the back and brought the CH to the front. What have I done here? I have switched to. So whatever this is, my molecule is not this. My molecule is the other one. So what is this? 1, 2, and 3. This is R. But it is not R what we were looking at because we exchanged it. So that one has to be S. If you have a question, you ask now before we go.
Hold on, so it's.
Well, wait a minute,
So that's
you
the
said
second one?
it's S?
What do you mean, okay?
Like, that's not illegal. No, I know. But I meant to say, like, you know, that it's not against the rules. Yeah, not illegal. I use the right term.
You can do whatever you want. You can do this. You can show your work on the test for whatever problem you want, as long as you get this right. And you didn't get it from somebody else. That's fine with me. It's not illegal. No,
S because
it is not illegal. But if you do it with another professor, the other professor might tell you, "Why are you doing this?" Another professor, but then you don't have another professor, do you?
No.
I don't understand the first one. You said we skip. What is it that we're skipping?
Skipping.
He said it should be R, but why is it S? Because there's
Because the
backwards.
hydrogen's in the front. So it's clockwise like R, and you're gonna ignore that, you just say this.
Just do the opposite.
Why?
You have a question? What do you mean why? Because it's supposed to be in the back and it's in the front.
It's like the opposite.
You gotta turn it around.
Why does it have to be in the front?
That's
Why
why
does
it's
it have to be in the
not.
back? Why does it have to be in the back?
Because lowest priority.
Because it's the lowest priority. Hydrogen is the lowest priority.
Because those are
so
the
it should be in
rules.
the back. But if it's in the front, you have to
So
swap the
if it's
hydrogen.
R, if the element in the back is a 4, right? Is it always gonna be like that, or is it
No.
Oh.
all the time?
It's not, sometimes it's S, and the priority, they had lowest priorities in the back. You can do this when the lowest priority is in the back, is when you're supposed to determine what it is. But if I don't give it to you like that, this is not like you wanted it, yes.
Correct.
You wanted this in the back, and I didn't give it to you like that.
And since we manipulated it, that's why
So,
it's S.
you have to manipulate it either by switching to, or by understanding this is in the front, and the rotation is not gonna be like this, because
Right.
this is in the front, it has to be the total opposite.
Right.
So instead of R, which is what we measured, is S, because this is in the front, and it's supposed to be in the back. It's opposite of what it's supposed to be. And why is the hydrogen supposed to be in the back? Because everybody assigned it this way. Let's do another. So that's, the enantiomer of that one is this one. Yes or no?
Can you do like the next example that you do? Can you do something like how it would be on the test, like a test question? Like how would I see it on the test?
This is a test question.
No, but how would you?
That's a test question. But the mirror image of this looks like this, okay? Cl, Br, and this H, and this CH3. If I assign priorities, this is 1, 2, 3.
No, 3 would be
Three.
3,
And that's
then
4.
that's 4. And
Very
that's
nice.
your-
This rotation is what way?
It's
It's
counterclockwise.
It's supposed to be
S,
S.
but it's R, because you have that
That's
H.
right, but this is in the front, so this is actually
R.
which is the opposite of this.
That's it.
Now, if we were to draw the what was that, the
That was the S that answer. We already did
So
that
I'm
one.
saying the question would just be that like, where you just like without all the.
Okay, so
I got it.
Okay, so my question is, if we decide to draw S, like let's say for on the bottom, on the second part, we write it into the mirror image of that, it's going to be S, but technically it's R.
No, it's just
I
R.
think we're thinking too much.
It's an R.
Yes. But let's do more, okay? So relax, breathe deeply. And if you think it's bad up to now, it's going to get 5 times worse.
No, it can't be.
I just don't know what it's right.
They're all that on the left is two of the same thing as this one. Like either one of those. He's just saying.
Okay, I don't want you to say anything. I want you to try to figure the thing out. Now, the priority does not even need to be a hydrogen, yes?
No.
Right. The lowest priority here is not going to be a hydrogen. What is the lowest priority there?
Carbon.
CH3. CH3. CH3 is the lowest priority. Do you guys hear what that lady's talking about next door?
No.
It's 1046.
Really?
You made it 1046, huh?
I
Yes,
had
you
two
did.
professors, how weird is that? I mean, it was,
You had 2 professors?
yeah, it was like, when I had it for summer, remember, I had 2 professors, it was weird, like, different teaching styles. It was
In my
like-
class, you had 2 professors?
No, when I had the lecture.
Yeah. Oh, okay.
I hated that, it was horrible. One couldn't understand, the other one you couldn't understand, so lose-lose.
Wait. Could you please repeat what you said about the carbon?
CH3 is the lowest priority. We come here to assign priority, yes?
Yes.
This is a carbon. Here's another carbon, yes or no?
Yes.
Okay, so we cannot assign priority based on that.
No.
We go to the next. Here's a hydrogen, and here is a carbon. Which one is lower priority?
That one.
I'm so
Okay. What's next? Okay, so which is this priority?
One.
This one?
Three.
Is this 2?
No, that's two. That's 3. And that's 4 up there.
Very nice.
So it's supposed to be an S, but it's
Now
an
tell
R.
me,
It's
if,
an R.
if this were here in the front, the lowest priority in the front, I could just do it and it's a reversal.
Right.
If it was in the back, I could just do it and it's that. But this is there. I don't want you to try to figure this out.
We can't switch it?
You
Yeah.
want some of the.
You can switch it.
Okay,
You can switch it. But I don't want you to try to figure it out by looking at it.
right.
Because in reality, what you're supposed to do is, you're supposed to get underneath. If you reach that level of understanding in the class, you can stand underneath this thing here I know that this is in one room, this is here, and the other one is here. And you can see that the rotation is from bromine to the other one to the other one. But if you cannot get underneath, then what do? You change the two groups. Yes? So I'm going to redraw the same thing. Which two groups am I going to change?
Bromine.
I'm going to change
Chlorine.
the lowest priority to the back. I'm going to put the lowest priority here, and whatever it's here, I'm going to put it up there. And this is CH2, CH3. And this is still Br. And the priority is 1, 2, 3.
It's still out of order.
Excuse me? What's still out of order? Who's out of order?
No, it's in order.
It's
You
not.
just go that way. You don't have.
So now, this is 1, 2, 3.
There you go. Yeah.
Supposed to be R. This is R.
Yeah.
But this is not R, this is
S.
S. And this is what we did when we stood underneath it. It went like this, yes?
Yeah.
You saw it or no? Did you put yourself underneath this? So that's the enantiomer. If I wanted the mirror image of this, then you redraw it. I think we can call that a day, yes?
Yes.
You want to call that a day?
No, I'm not sure.
You have an exam next week.
Can you pass the attendance here?
Where's the attendance at?
Are you gonna send us a review?
I'm going to try to put this, I'm going to try to put this online. And when I do on YouTube, I am going to send you a link. You can stop this. Can you stop
Yeah,
that?
yeah.
Just stop.
I don't want to touch anything wrong.
Why not? Is it going to bite you?